Welcome. I'm Bart Poulson, and I am here in Data Lab headquarters to talk to you tonight about not all roads lead to Python. And before I get started about that, I would love to invite you to add a comment and tell me where you're tuning in from. What country, what part of the world. I'd love to know who's out there. So put a comment in and we'll see who's showing up. I am in Salt Lake City, Utah, and it is the evening here for me. And I'm doing this in part because when I do my other events, I know that people on the other side of the world from me, so people sometimes in Europe or in Northern Africa, Middle East, or India in particular, are up there in the middle of the night. And so I'm trying to pick something that might work a little better for people in the Western Hemisphere. And so I see we've got Desiree in Utah. We've got Priyanka in Idaho. So these are people who are in my time zone. Jamie in San Francisco, Sierra in Chicago. So I am actually getting a lot of local people. Okay, Rahul is in India. Talia is in Salt Lake, where I am. Andres is in Costa Rica. Ranita is in India. Alexander is in Calgary. Bashir in Yemen. Afsane in Australia. And then we have Michigan and Sydney, Australia. Well, folks, thanks for tuning in. And I hope that this time is a useful one for you. On the other times that I do events, I do them in my morning time, 10 a.m. Mountain Time. And so hopefully those work well for some other people, depending on your schedule. But I see we've got people from India, from Mexico City. And, I just have to say, this is really gratifying to me. So thank you for joining me. Now, I need to start by explaining what I mean, not all roads lead to Python, and why I want to talk about this. It comes from another LinkedIn live event. So one of these live webinars that I did with a friend of mine, Keith McCormick, and we were talking about the statistical program SPSS. I've done several courses for LinkedIn and for my own company, datalab.cc, on SPSS. It's something that a lot of my students at the university where I teach is what they use. But one of the comments that we got in that LinkedIn Live on SPSS suggested to the person that everything was preliminary and every software package was there just as a way to help you get started until you eventually ended up in the only true statistical package, Python. That was the only way that real people did data science, and that everything else was simply an intermediate for people who weren't yet comfortable with Python. Now, I understand that's true. Python's an extremely popular language, and it is a very in-demand one, but often for kinds of different things. The trick with Python is if you look at anything about the popularity of Python, the programming language, say with R, another programming language that's frequently used for statistics, is that Python does anything. If you want to write a video game, you can do it in Python. If you want to create a web service, you can do that in Python. Might not be the first choice, but you can do lots of things aside from data analysis. In fact, the data analysis part of Python came in much later. And when you look at the overall popularity of Python, it's because you have these other things rolled into it. There are some very significant important developments for machine learning in Python, although truthfully, anything that Python can do, R can do. And R is, for instance, specifically focused on data analysis, but there's so many other ways to work with data. I've worked with Python. I am more comfortable with R, but even then, I only open R when I have something very special to do. Most of the time, I am doing my work in a spreadsheet. I use Google Sheets every single day. I do so many things in it. Like if I just need a numbered list that I can copy and paste into somewhere else, I'll do that in Google Sheets. And when I need to do statistical analysis with one of my colleagues or with a student, now a lot of them assume that we will use SPSS because that's very common in the university setting where I work, but I actually recommend a different program called Jamovi. That's Jamovi. It's a free open source program that resembles SPSS, but actually runs on R. And I think it's a great introduction. But before I go much further, I want to ask you again for a little bit of input from your comments about what kinds of data tools do you usually use in your work? Do you use Python? Do you use R? Do you use SPSS or Stata or SAS? Do you use spreadsheets like Google Sheets or Microsoft Excel? And what do you do with them? And I guess also, are they meeting your needs? So let's just ask here, what software do you use? Okay, so that is the one that we want to use right now. What software or what languages do you use when doing your data work? And so I'd love to know what kind of comments you have for that. Okay, so Alexander says Excel, which is probably true for, I don't know, a few billion people in the world. I use Excel all the time. But what else do you use? So let's go back to, we have Excel for rudimentary queries, not meeting needs. Okay, so it starts, it's something to work with, but it does have its limitations. We'll suggest a situation where you would want to try to use a different tool. What else? What else do you use? Okay, here we have another R person. And again, that's like me. One of the interesting things about the R versus Python debate is it serves as a sort of almost like group indicator. People who use Python, in my experience, usually come from a computer science or programming background. People who use R usually come from a research background, which means that they're involved in something else and they use data as part of their work, but it's not the full thing. Here we have Microsoft Excel, PowerPoint, and Spotfire. I'm actually not familiar with Spotfire. We have another Excel. What else do you use? How do you actually work with data? You know, I'm not necessarily looking for what's the fanciest one that you use for the high power, but if you had, for instance, to put together a quick report, what would you use? So I'd assume Bo would use Excel. Again, probably the single most common data tool in the world. And a lot of people who use it don't necessarily think of themselves as doing data work. All right. Desiree has used spreadsheets. Good for you. They're sort of a universal data container. I have an untested theory, by the way, that by head count, meaning by separate files, there are probably more spreadsheet files than any other form of data in the world. It may not be for the size of the data. Oh, Alexander, you're asking for an average Joe. Do I think Excel or even Jamovi is more than enough? Yeah, I think between the two of those, you've got what you need in most situations. You know, it actually gets back to what my purpose was, the description of this thing. When I say not all roads lead to not all roads lead to Python, the idea is that you need to choose the tool that matches your goals. What are you trying to do? You know, there's not like, if you're cooking, there's not one best knife to use. The knife that you use depends on what you're trying to cut. You don't cut a fillet with a bread knife. You don't cut, you have so many different things that you use. You know, if you're working on, I'm working on my bicycle. I have hex wrenches, I have Torx wrenches, I have open-ended spanners. I have a lot of different tools that I use. It depends on what I'm trying to do. And so I think the idea is that for most questions, I would say start with a spreadsheet. So Excel or Google Sheets. I like Google Sheets simply because I don't have to open it. It takes like 30 seconds for Excel to start on my computer, and Google Sheets starts immediately. That for me is a nice thing. The general rule I say is number one, start with a spreadsheet and use that until it no longer works well, works easily for your data. Then at that point, I would recommend going to a statistical application like SPSS or Jamovi, something that has drop-down menus that makes your life easy. For a lot of people, that's also going to include something like Power BI or Tableau, or Domo, something that is designed already to make your data work easy. And then you may come to a point where the stuff that you're trying to do is not easy in those. If you're trying to do, um, say, for instance, you're trying to do a neural network, SPSS just isn't going to do it in any acceptable way. You're going to have to go to a programming language like R or Python. But the idea is you don't necessarily need to start there. I love R, but I only use it when I can't get the other stuff done in a spreadsheet or in Jamovi. I use Jamovi for anything that is beyond Excel, but I'm not quite yet ready to fire up the full R thing. On the other hand, if you're a person who is in fact already using something like Python all day, you're already there, it's already up and running, then maybe it's not a big deal. So the question, say, Alexander, really the question here is Excel or even Jamovi more than enough? It depends on what you're doing. If what you're doing is making bar charts and line charts, which I personally believe are adequate for 90% of data analyses in applied settings, if you're doing those, Excel or Google Sheets works great. It is a completely sufficient tool for those analyses. On the other hand, if you want to do a regression equation, or say, for instance, you want to do a dot plot chart or a box plot, Excel doesn't do those easily. Neither does Google Sheets. It can do them. It doesn't do them easily. And in that case, I go to Jamovi. And I use Jamovi unless and until I have to do something very specific that requires R. So for instance, I find data cleaning to be really easy in R. And part of that is because I get to save all of my code and I can execute it over and over and again. I can import the data file, I can rename things, I can select and reorder things very easily in R. So data manipulation, I find, is really easy in a programming language, but simply sorting through the data and making basic graphics, which again, I believe constitutes 90% of applied data work, that's really easy in Excel. So tell me what kind of tasks you tend to do repeatedly, because that can help make the decision. So let's say, what data tasks do you do repeatedly? So not the biggest thing that you've done once, but what's something that you've had to do several times or maybe even on a weekly or daily basis? What kind of tasks have you had to do? If you can put those in the comments, we can have a little discussion about what kind of tools would be most useful for those. And maybe there's a situation where a spreadsheet would be perfectly adequate. Maybe there are other ones where you would need to go to an app or even a programming language like Python. But tell me what kind of things that you are actually doing. So we have a question here about SAS for data manipulation, and the answer is I don't know. I have not used SAS in 30 years. I know SAS is an extremely capable language, and I imagine, but I don't know from experience, that SAS would be very good for doing data manipulation. Let me ask the person who mentioned that, have you used SAS for data manipulation, or do you use SAS on a regular basis? Because that's going to influence it. And then in the meantime, let me go to this one. Is Power BI going to replace Excel? No, they're different tools. They have different purposes. In the same way that, a blender is not going to replace a chef's knife. They both cut things, but they do it differently. The blender is really good doing it at scale. It chops a lot of stuff really quickly, but they are different tools. The trick also is that Power BI, for those of you who are not familiar, Power BI is a Microsoft application that is sometimes seen as a sort of an advanced version of Excel, but what it really is it's a wonderful tool for interactive data visualization and creating dashboards. I think dashboards are enormously useful in organizational settings. I have tried to use Power BI. I assumed it was going to be like Excel. It's not. It's a totally different tool. But I know people who work for global industrial companies who are in Power BI all day, every day. It is the perfect tool for what they need to do, which primarily is preparing visualizations for presentations. Tableau is also a very good one for that, but I see them as fundamentally different tools. I wouldn't also, there's not an easy free version of something like Power BI. I know there's a free version of Tableau, but it's only if you share all your data publicly. I really like making tiny spreadsheets and using them for one-off purposes. So I don't see Power BI is a big tool, and I don't see it replacing Excel. Alexander says data entry, sorting, filtering, and graphics mostly for somebody else. Excel works great for those. Now, the trick with Excel, and this is the one thing I have to say about spreadsheets in general, or any application with a point and click interface, you may be familiar with the computer science expression, point and click doesn't scale. What that means is if you get a new data set, you got to do it all over again. You can't automate it. Now, the fact is you can automate it. If you're in Excel, there is something called VBA, which is Visual Basic for Applications. It's a programming language that you can use in Excel, but VBA is a very special thing. And in my mind, if you're going to use VBA, or Google Sheets has a, I think it's ActionScript is a similar thing. If you're going to use those, you might as well be using a programming language anyhow. But things that you have to recreate from scratch each time, those are a pain. And that's where you want to get to something that allows you to write code. Now, an application like SPSS or SAS, although they have point and click, they also let you save things as code. In SPSS, those are syntax files, and those can be run again and again and again. Every time I use SPSS, I save everything as a syntax file so I can recreate it. And of course, if you're working in Python or R, you're writing lines of code, and those are so easy to replicate. And it's also easy at times to show other people exactly what it is you did. So that reporting ability is one of the strengths of those. The repeatability and really the transparency of the process is very helpful. So for data entry, sorting, filtering, and graphics, I would probably start with Excel or Google Sheets. And then we have data wrangling and regression analysis. Data wrangling is going to be easier in a programming language, Python or R. R in particular is well suited for that if you use the dplyr package. That's dplyr. The dplyr package is a gift when it comes to wrangling data. And regression analysis, you wouldn't want to do that in a spreadsheet. That can be done in SPSS. It can be done in Jamovi for most versions of regression. If you're going to get extremely fancy, then you would want to use R or Python. Jamie says, filter data, explain restriction, note variances and dependencies. I assume that's one you're going to want to do either in a statistical application like SPSS or SAS, and then you could also do it in a programming language, if that's something you're comfortable with. And linking multiple reports to spot new trends. Okay, that immediately jumps out to me as something that you would want to use R Markdown. So Jamie, actually, do you have any experience with R Markdown, which is for creating documents with embedded code? It actually can facilitate this kind of reporting, especially if it follows the same format on a regular basis. And then, so we've got some different situations that people are working with. Now, let me ask another one, and this is one that you can give a very quick answer to. How many of you, Jamie, R Markdown is something you might want to look at. If you're familiar with R, it's a different way of working with R. It puts it into Markdown language, but you can do it in RStudio, and it does allow the creation and exporting of documents. I've got this much experience with it. Other people use it all day, every day. If you're doing reports on a regular basis, our Markdown can be a really great thing. Um, Let me mention also that I've touched a little bit on collaborating with other people. When if you're doing analysis for other people, or if you're working in an organizational setting, you want to make it so that your work can be easily shared with others. That is uh, that's a good reason to have something that has code that can be easily audited. So the syntax in SPSS or programming language, because it is very easy to look at exactly what happened and see it line by line. That's hard to do with Excel. Excel is very flexible. It's also easy to screw things up in Excel. And so you need to be careful. Um, let me come back to this one. Alexander asks, is there an equivalent in the Python ecosystem for R Markdown? Um, well, I don't know, except I do know that R Markdown can use Python. So, but you use it in RStudio, and you simply indicate that this code is done in Python. The rest of it is in Markdown. So it is possible to use Python in R Markdown. I don't know if it's going to be easy because you are using it in the RStudio interface, but the people who make RStudio have been working hard to integrate Python and other languages like Julia JavaScript into their abilities as well. So you may want to just Google R Markdown Python, and you will be able to find at least some examples and determine whether that works well for you. The other thing I want to say about collaborating really is a lot of times you work in an organization where, for instance, they tell you what software to use, and maybe they don't allow you to install software on your own. And those are important restrictions. And so I imagine that some of you are working in situations where that might be the case, where you would like to use an application like, say, for instance, Stata. Let's say you're familiar with that, or Minitab, and you would like to use it, but your organization doesn't support it, especially the things that cost money, or they don't allow you to install your own software. That's true at a lot of places. Well, the way around that, number one, is you can use cloud-based ones that run through the browser, so you don't install anything. When I use Python, I don't run a local version of Python. I find it to me, it's too messy and there's too many things going on. I use Google Colab, which lets me do Python in the browser and using their servers. I think it's a great way to run it, and it gets around the problem of not being able to install software. There are cloud-based versions of R. There's a cloud-based version of Jamovi. And so if you're looking for something that has the point and click interface, the cloud-based version of Jamovi is a wonderful way. And so I'd be interested to know whether any of you have to deal with those restrictions. Say, for instance, you work for an organization that says, this is the software we use, or you're taking a class and they say, this is the software we're going to use, or they don't allow you to install your own software, or the other software just costs too much, or it won't run on your particular computer. I'm a Mac user, and so I have never used Amos for structural equation modeling. That's often goes with SPSS, even though I have a license for it. It's a Windows only application. So if I ever have to do structural equation modeling, which I've done like twice in 30 years, I use R to do that. I would love to hear about the restrictions that you have. Do you work for an organization? They say, we use this software, or this costs too much, or something that constrains your choice. That would be an important one. In the meantime, I want to look at this one comment from Tori, who says, so it's changing topics a little while you guys respond to that other thing. In 10 years, how do you think the majority of data science students will prefer to learn their craft? That is boot camps, university, web-based, self-paced, etc. You know, it's funny you should ask that, because that was the topic of my last office hour. It was called that office hour, which you can, it was recorded and the video is available on LinkedIn and on YouTube and Facebook. We had a session we called Autodidact Swagger, where autodidact means being able to learn things on your own, being able to teach yourself. My experience is that when it comes to these technical things, A huge amount of it is learned on the job, and a huge amount of it, even if you learned it in a classroom, maybe you weren't really paying attention. And it's not until you actually have to use it to do something that you then finally pay attention and get to know how it works. I took a SAS class when I was an undergraduate many years ago. That's when I used SAS, but then I hit a roadblock and I couldn't solve a problem, so I had to learn to use SPSS instead. Um, I learned how to use R on my own. I learned how to use Python on my own. I learned how to use about 8 other applications on my own. Um, Boot camps, and I do not have experience with boot camps, and so I don't know. I'm a university professor. I'm a big fan of the university setting, and I try to do things that make it so my students can learn these tools in the university setting. I hope that university would make those things more accessible. Web-based, self-paced, everybody in the world goes to YouTube, and YouTube's a great place to learn things. I also make videos for LinkedIn Learning. I strongly encourage you to take a look at that if you have access to it, either through your job or through your university or through your library. Of course, you can get your own account as well. But those would be wonderful things. Now, I see a few people here have responded to the question about restrictions. So Yvette says, governments do not like the studio versions. I assume that means our studio. Yeah, the governments are going to place some very, very serious restrictions around what you can install. And sometimes it takes a significant thing to make it happen. Jamie also deals with a restricted situation. Alexander says that his company has pushed the adoption of Python instead of R, but R is not forbidden. It's based on use cases. You know what? For people who want to be practicing data scientists, if that is what you want your job description to be, then it actually is good for you to know how to use both R and Python. The nice thing is ChatGPT can usually help you convert from one to the other, except for when it does crazy things, but it's a nice way to get started. Jamie says the LinkedIn series, I learned stuff on LinkedIn Learning, and so I think it's wonderful. And so Yvette says there are restrictions on using SAS in her environment also. So believe it or not, our time is nearly up, but I appreciate the questions you've had and the feedback you've given. But really, my big point here is working with data is a wonderful thing. I think working with data, even just a little bit of data, just getting started is one of the most important things that an organization can do. But you don't have to start by being rocket scientists. You can start by being people who count and who measure and who look at things. Spreadsheets are a great place to start. Google Sheets and Excel are a fabulous place to start. They're good for browsing, they're good for entering, they're good for sorting, they're good for filtering, they're good for bar charts, and they're good for line charts. Use them. Also, there will come a time, perhaps depending on your tasks, if you need to do a regression, you're going to want to go to an application. And if you're trying to do something more sophisticated than that, if you're trying to do a neural network, or if you're trying to do serious data manipulation, then a programming language will be the tool that makes your life easier. And so the whole thing is, Python is a wonderful language. I don't mean to bash Python. Python is a wonderful language, but make sure that you are choosing the right tool for the job. And in most cases, that right tool is going to be a spreadsheet. And with that, I'm going to say thank you so much for coming. And I will see you hopefully in either the second Thursday of next month or the third Tuesday. Thanks so much for joining, and we'll have a recorded version of this on LinkedIn, YouTube, and Facebook in the very near future. I'm so glad to have you join me. Bye-bye.